3 or 4. Okay, so I already know the probability that the number of red apples is 4. I've already got that. So I'll just need to work out the probability of selecting 3, because more than 4 is either, more than half is either 3 or 4. So the probability that the number of red apples is 3, well, it's just going to be the number of ways I can do this. So that's going to be the number of ways I can choose 3 red apples, and so that's 10 choose 3, times the number of ways I can select 1 green apple, which is going to be 5 choose 1. And I divide this by the same thing, which is 15 choose 4. So my denominator is the same, it's 1,365, but my numerator this time is different. So it's 10 choose 3, which is 120, multiplied by 5 choose 1, which is 5, and I can just key that straight into my calculator to get an answer here. And this is the probability then that the number of reds is 3. So all I need to do now is add these two probabilities together, and that will give me my answer. So I just add 0.4396 to 0.1538, and so my overall answer here is 0.5934. There's my answer, and that's the probability of the number of reds being 3 or 4. That's more than half. Okay, let's have a look at this question. The letters of the word statistics are arranged randomly. Find the probability that the resulting string of letters begins with 3 S's. So in order to figure this one out, we have to think how many arrangements are there that begin with 3 S's, and then divide that by how many arrangements there are in total. So let's start with the total number of arrangements. Well, so I'll just put total. So we've got 10 letters, so that's going to be 10 factorial, but we've got a bunch of repeats. We've got 1, 2, 3 S's, so I divide by 3 factorial. I've got 1, 2, 3 T's, so divide by 3 factorial again, and then I've also got 2 I's, so I divide that by 2 factorial. Put this into my calculator, and it's 50,400. Now I'll work out how many arrangements there are that begin with 3 S's. So the SSS ones. Well, if I begin with 3 S's, they're accounted for. So there are 7 letters remaining. So there's going to be 7 factorial ways to arrange those. But there are some repeats because there's 3 T's, so 3 factorial. And there's also 2 I's. So then work out 7 factorial divided by 3 factorial times 2 factorial. Key that into my calculator and we get 420. So the probability this happens is the number of ways when there's 3 S's at the start divided by the total number of ways, and we get a pretty small probability here. Keying it into my calculator, we get, well, I get 1 over 120. So there's the probability. Okay, how about this? Begins with 3 identical letters. Well, for this, I think we could just separate this out. It either begins with 3 T's or it begins with 3 S's because there's only 2 letters with 3 repeats. So the probability it begins with 3 S's, we've worked out. The probability it begins with 3 T's is going to be the same as the probability of it beginning with 3 S's. So all I need to do is double my answer from before, and I get 1 over 60, and that's the probability that it begins with 3 identical letters. Okay, last problem here. A class has 12 boys and 8 girls. The teacher selects 6 students. Given that they select at least 4 boys, find the probability that they select exactly 2 girls. So for this one, we use this principle of the number of favourable outcomes divided by the total number of outcomes. So the total number of outcomes is the thing that's given. So that's that they select at least 4 boys. So we first need to work out the probability that they select at least 4 boys. Well, they're going to be selecting 2